Number 3, we're trying to find an equivalent expression. Once again, the first thing we're going to be looking for when we're doing these problems, if we can, is if there's a number next to a set of parentheses where they're adding or subtracting inside the parentheses, we're going to try to use our distributive property. Another thing we're going to look for is trying to combine like terms. If neither of those things work, those are the cases where we might add the opposite, or if they're adding, we can use the commutative property and switch things around here. So number 3, this is a case where we have some like terms here we can combine. Notice there's no subtraction going, so we don't need to worry about adding the opposite before we do this. We can add these together since they both have x's behind them. 3/5 x plus 3/5 x would be 6/5 x. So we'd have 6/5 x plus 2/5. 6/5 is the same as 1 1/5. You could change that. It's not any problem where they're telling us a real life situation or anything, so we're just going to go ahead and leave our answer like that. 6/5 x plus 2/5. Continuing on, number 4, we want an equivalent expression for this. And like I said earlier, again, our first two things we're going to be looking for is to either distribute or combine like terms before we do anything else. So looking at for like terms on number 4, we can see we have two terms that have h involved. Those are going to be like terms. Now before we do anything with those, we may want to go ahead and add the opposite back here. Make that plus a negative 2h. Another thing we can do, we can take our h in the front, and it doesn't have a number in front of it, means we could put a 1 in front of it. Okay, h is the same as 1h. So you may want to put the 1 in front of it there, and then we can combine these h terms together. So combining the h terms together, we've got 1h plus a negative 2h. Remember, this is like they're fighting it out. We do have more negatives than positives by 1, so that would be a negative 1h. And then also, we have some constants that are like terms, are both positive here. So we've got this, 5 plus 3 would be 8. So we'd end up, would have negative 1h plus 8 would be our equivalent expression there. You could also write this as 8 plus negative 1h. The reason I just started with the h before the constant is that the first term in our expression here had an h in it, but either of those would be the same. Those are equivalent to each other. Number 5, once again, we are looking for an equivalent expression. This one, they wouldn't have had to have the parentheses there. Notice there is an addition sign in between our first term and the set of parentheses. The number's not right next to the parentheses, so we're not going to be distributing here. We're not going to be distributing. They actually would not have needed these parentheses then in this problem. So if you want to think about the parentheses not being there, that's fine. So in this problem, again, not worrying about the parentheses at all. We have two like terms here that have b's. We don't have any subtractions, so we don't have to worry about adding the opposites at all. These both have common denominators, so 2/8b plus 3/8b would give us 5/8b. And then we'll just put plus 4/5. 4/5 is not a like term because it doesn't have a variable next to it. So that would be our equivalent expression. Look at number 6. They're asking for two expressions that are equivalent to 4n minus 5. If we look at this problem again, our first things we're looking for distributing. I don't see any parentheses, so I'm not going to be distributing. We're going to look for, can we combine like terms? No,
Nope.
these are not like terms. So this kind of just leads us to do some little tinkering with this expression, some slight modifications that will give us an equivalent expression. So probably the best option for this problem is that they're subtracting, we can add the opposite. So our 4n minus 5, if we add the opposite, two sign changes there, change subtraction to addition, that's going to become 4n plus negative 5. The problem asks for us to write two expressions that are equivalent to this. So that's given us one equivalent expression. We need another one yet, though. They are adding, so we can use the commutative property, and we can rearrange this. Anytime things are being added, we can rearrange the order we add them in, and we'll still get the same answer. So negative 5 plus 4n, again, taking these terms, just rearranging the order. Just like if we do 2 plus 7 is the same as 7 plus 2, 4n plus negative 5 is the same as negative 5 plus 4n.
So the second equivalent.
Number 7, they want an expression equivalent to this. 5 times the quantity, 3 halves r minus 8. And it says, state the property that justifies your answer. So again, we're not just after adding the opposite and saying that's an equivalent expression. I'm not going to give you credit if you do a problem that way. We're going to try and do as much with this problem as we can, because next year we're not going to do a lesson that says we're going to add the opposite and make an equivalent expression and be done with the problem. We're going to be interested in simplifying things, distributing, combining like terms. So that's going to be what we need to do on a problem like this if we can. So this one, we have a number right next to the set of parentheses, means we can use our distributive property. When we use our distributive property, again, drawing those arcs to show that we're multiplying is probably a good idea for us here. We're going to take 5 times 3 halves r, and then minus 5 times 8. If you looked at this problem and you added the opposite right away, that's fine. Again, don't make that be your final answer, but if you did that, you're okay. We'll just continue on, and your answer will look a little bit different than what we're going to get, but you'll still be fine with that. So if we look at this, to multiply these, we need these both to be fractions. So 5 we can put as 5 over 1. 5 divided by 1 is still 5. We'll multiply straight across. So 5 times 3 is 15. 1 times 2 is 2. So it would be 15 halves r. We can change that to a mixed number technically. This case, again, we don't know what's actually happening in this problem, so you can just leave it as an improper fraction as long as it's reduced. And then this would be minus 5 times 8, which would be 40. Okay. Now, if you added the opposite at the beginning of the problem, your answer would look slightly different. You'd have 15 halves r plus negative 40, and that would be the same. That would be another equivalent expression. So either way would be fine for that. One common misconception some people have is looking at this as we're multiplying 5 times 3 halves r and questioning that we shouldn't be able to do that on the fact that those are not like terms. You are allowed to multiply terms together whether or not they're like terms or not. What you're not allowed to do is add or subtract terms if they're not like terms. So we can multiply them. We're not going to do it right now. You could divide them if they're not like terms. What you're not allowed to do, again, is you cannot add them together if they're not like terms. You cannot subtract them if they're not like terms. Number 11 asks which shows an expression equivalent to 6x plus 8 minus 4x. So if you'll notice, as you look at this, they've got it set up pretty nicely for us. All of our answer choices, if you'll notice, are simplified. In other words, we're not having anything on A, B, C, or D that would allow us still to combine like terms or allow us to distribute. Those are already simplified all the way down. What's not simplified is the part in our question there. So on this problem, what we can do is we can combine some like terms together. You might be able to look at this and see this as we've got an x term 6x in the beginning, and you might be able to look at that as a minus 4x and say, well, 6x minus 4x is 2x. Some people have a hard time seeing that, or they miss that sign otherwise. So the other option we have always when we're subtracting is to add the opposite. So we could change that to plus a negative 4x. When we work that out, then 6x plus negative 4x, they're fighting it out. We got more positives here by 2, so that'd be 2x. And then the plus 8 just comes in behind there. Again, those are not like terms. We can't combine them, and that matches exactly with answer choice C. Number 13, they're asking which of the following expressions is equivalent to negative 2/3 x plus 2. Select all that apply. This time, the negative 2/3 x plus 2 is already simplified. Nothing to do there. It's kind of backwards. Several of our options in this case, we can do some stuff to simplify them, combining like terms and things like that. So we'll want to do that and then see which all of these answers are going to be equivalent. If we look at our first option here, they're subtracting there, so if you want to add the opposite, you can. And then in order to make it look like what we had to start with, you can rearrange that as negative 2/3 x plus negative 2 using our commutative property. Obviously, adding 2 and subtracting 2 is not the same, so that's not going to work. If we look at our second option here, once again, they're subtracting. We can add the opposite. We switch and rearrange this with our commutative property. We got negative 2/3 x plus 2, and that's exactly what we wanted, so that works. The next option, again, you can add the opposite here if you want. What's going to happen here, we have two constants we can combine together. So negative 1 plus 1, those would actually cancel each other out, so we'd just be left with negative 2/3 x. So that's not going to be the same. The next option, again, if you want to add the opposite here, we've got negative 1/3 x, and this would be plus negative 2. We got two problems there, and we might recognize even just looking at it, negative 1/3 x, there's nothing that's going to change it. There's no like terms. Obviously, we're not going to get a negative 2/3 x out of that, so we can kind of just quickly bypass that one. And then our last option, again, you can add the opposite here, and we can combine these together. So we got negative 2/3 x, and then this would be plus 2, and that's exactly what we wanted again. So the second and the fifth options would be the two that would be equivalent there. Number 14, they give us a bunch of information about Diego and his rectangular model bridge. If we read through all this stuff, basically what it boils down to, they're just asking which expression is equivalent to that. So we really didn't need to know all their details there. That was nice of them to share that, but we're just finding an equivalent expression. So if you look at this one, with how it's set up, looks like we need to use distributive property. So we do 1/2 times x and then plus 1/2 times 8. So 1/2 times x is just 1/2 x, and then we know half of 8 is 4, so that matches with answer choice B. So this gives you an idea about how to work with equivalent expressions.